Hello and welcome to another video lecture here at Data Science Labs. In this video, we're going to cover 5 basic operations within the regular expressions library. Those functions are going to be the match, search, find all, sub, and subn functions. Now, if you're starting your data science journey or you're well along on it, you'll quickly find at some point that regular expressions can be really useful if you have to deal with text data. And even if you're dealing with quantitative data, it can be really handy when you need to do a lot of data file parsing and you need to match, searching through a directory and pull specific files. So whether they're named in a certain, stylistic pattern or if they have contents that follow a certain sequence. Regular expressions, as we mentioned in the last video, is a very powerful library for describing and creating patterns that we can then use to query textual data. And that querying can help us with doing filtering, validation, transformation, or general search queries. Now, if you like this content and video and you want to see more like this, go ahead and subscribe to our channel. But for now, let's go ahead and dive into the different functions and applications. I'm going to start off by doing a quick load of the data set. So first I'm going to import the regular expressions library, and then I'm going to import pandas. Now I've created 2 dummy example files here for us. We've got a contact directory that represents sales data, and then I also have a report file directory that we can use to simulate digging through quarterly reports with regular expressions. So we'll go ahead and get started. I'm going to import regular expressions, and I'm going to import our contacts data set. So that's df contacts. So we see that that's loaded, and just to verify that, I'm going to go ahead and create a new cell. And let's just sample the contacts data set just to give you a flavor of what it looks like. So I'll do .sample, and we'll show just 5 of these here. So we'll go ahead and run that. And you can see, so email, a little bit variable. It looks like we don't have that many. But again, this is a sample, so some we might, some we do. Phone numbers, the style that these phone numbers are put in are also non-uniform. So that can be somewhat problematic if we're trying to send out an auto, text or kind of SMS service. We have to be able to handle these different number contexts. If I do a different sampling, you can see here those phone numbers are even more varied. We've got some parentheses, some with dot notation, some with hyphens. And then on the email side, we've got some, a lot that are missing, it seems like. And then some that have different extensions like .com, .co, or this @invalid where maybe someone filled out the form, really doesn't want to be contacted, and so they just gave us fake data instead of just not responding. So that's the first data set we'll work with. The second one is this reports data files CSV set. So I'll go ahead and open that one. This one is really just a file directory, you can imagine. So we've got a list, a CSV file that tells us what are the files in this directory and what are their file names, anything we should know about them. So you can see here as I take my sample of 5, we've got market insights, purchase orders, annual reports, or other types. And then we got comments tagging each of those. So whether what's the document classification, who prepared it, some of that additional information. It's interesting, you can see here we've got some that say incomplete. And so it looks like someone tagged these data files so we could separate the full valid quarterly reports from the invalid ones. So that's going to be particularly helpful in our examples. Now, as we go into the first function, it's the match function within regular expressions. The way that we call this function is by providing a pattern at the beginning, followed by a string. And that string would be the text information that we want to search for a match on. Now, the important thing to call out here is that in the regular expressions library, match will search for a match at the beginning of the string only. So if it doesn't find a match at the beginning, it's not going to go through the entire textual string that you provide. This is actually really beneficial and because it's very efficient. So if you provide something that is thousands of characters long or hundreds of thousands of characters, If it identifies at the very beginning that it's not found, it's not going to bother going through the whole document. There are other regular expressions functions that can go through the whole document, and we'll cover that next. But this one is really handy for seeing, does my file essentially start with, or does my pattern, or sorry, my string start with this particular pattern? So it's very efficient, and that can be very useful. So as we dive into an example, if I wanted to identify or extract a list of report names that only included the quarterly reports from our report file directory for global operations, and I wanted to only have valid reports, so avoid the ones that say incomplete or invalid, I can use a regular expression.match function to be able to pull that. And the way that I would do that, I create this pattern you see here where we have any digit repeated X amount of times, and then the underscore quarterly report .csv extension. So, this is based off of that data frame sampling that we did here, where I can see here we've got this, here's my date stamp, and then global quarterly report. And so, I can apply that same application. Now, one quick nuance here is that you can see in this pattern, that one's a global, this one is just any digit. So it's not actually going to match this one for a global quarterly report. It would match on one that just has quarterly report after the digit string. So that's the way that we would construct the pattern. Now let's go ahead, and I think we've already loaded the data set, but just for simplicity, we'll add in this one as a simple data frame df. And then I've created this pattern, underscore global quarterly report. On the text file, if we want to look in the second element, so let me, instead of dataframe.sample, let's just do dataframe.head. So we want to see if the item in the second location, and since Python is 0 based, we're going to check in this location here, if that is a global quarterly report. And if it is, we want to see that match. So I'm going to go ahead and run this function, and we're going to see what match outputs. Now, one thing I did not mention is that match will provide us 4 main things. It's going to give us the text that was matched, the position of the start and stop of that match, and the span, in other words, how long it is in terms of character length, and the captured group. So if we had a special group or groups that we provided, it would give us those specific groups back as well. So in this example, I'm going to apply that pattern and use re.match on the pattern and the text we provided. And you can see here, when we print out the type, we do have a match object. We can see that the match starts at the first position, ends at the 36th. We've got a span from 0 to 36, and then this is the matched object that it returned to us, or the matched group. So this can be pretty handy for checking a single one. Perhaps we'd want to iterate through the entire list. Well, we could do something like using a df.apply or other mechanism to basically check and see, hey, which are matches, and extract those for me. So now, what happens if we don't get a match? Well, if you look up again the quarterly reports, we can see that this top one has a delete next to it. So maybe this one was invalid. We provide a very rigid rule structure where it has to start with a digit. So in this one, I'm going to run it and check the first location. And what we should get when we look at the type of the match is a none type. If there's no match, it's not going to return, it will return a none type object. And so, that is particularly handy. We can see here that it didn't find a match, and so it just returned our none object. Now, again, this is because it only matches at the beginning of the string. If I did a different mechanism, like a search or a find all, I would actually find this string because it doesn't start with it, but it exists later on in the text corpus. So now onto our second regex function, the re.search. In the search mechanism, the main difference here is that it will search through the whole document. So if we provide this string again, it will search through the entire amount, and then it will pull the first match back for us. So it provides the same type of information, the match text, the start and stop position, the span, and the captured groups. But instead of only looking at the first position, it will look all across the string. As you can imagine, this will take a little bit longer to execute. Now, for short strings like what we've been passing, it's not going to be a big deal, but this might matter if each string that you're providing are entire books, right? Or PDF content, or let's say they're lectures that you've got closed caption, voice to text strings coming out of. So you just want to be cognizant of the differences there in terms of efficiency. But for the search mechanism, it operates very much similar to the match. So in this one, let's give a example where we want to use it. So let's say we want to pull all the records from our report file directory that were prepared by this person named Frank, with a last name that starts with a B. Well, we can provide the pattern Frank B, and we're going to look in the comments section, because if we go back to our example in the comments, it looked like it provided a document classification and then who prepared it. And if that's not clear, let me just pull out. So we'll do df dot, let's see, the comment section. And then let's just pull out the first example so you can see what I'm talking about. Looks like I added a third M. Okay. So here we see in the comment, it gives us data classification, prepared by, and then who validated it, and then the reason it was prepared. So again, we want to find all the records by Frank. So I'll scroll back down to the problem we're working on. And we've got this pattern for Frank. We'll give it the text, which is the fourth row. So we want to check that the text information in row 4 and see if that contains Frank B in it. Now you might see some issues here, because if we're being clear, this would search and give us a match if it was prepared for or validated by Frank. So you want to make sure that you understand how this pattern is being recognized, because if you wanted to explicitly find only those that were prepared by, or only those that were validated by instead, you'd have to make your pattern more exclusive. So in this case, I'm going to run the pattern, and we're just going to see the results. So you can see here, we do indeed have a match for that fourth position. We can find that it starts at character 52 and ends at character 60. And if I were to go ahead and show that, so I'm just going to bring this out in the end of the string. So this is what the contents of that fourth comment are, document classification. And so you can see that Frank prepared it and then Bill validated it. Now, again, if there's not a match, we're just going to return a none type object. So if we were to check comment 3, we see that this was prepared by and validated by Bill. And so we shouldn't get anything back since we're searching for Frank. And you can see here we've got a none type object. So just to recap, big difference between match and search. Match looks at the beginning of a string and only the beginning. If it doesn't match it, throws it out, returns none. re.search will look through the entirety of the string and pull back the first one. If you got many instances of your match, it's only going to give you the first one. So maybe it was prepared by Frank and validated by Frank. It's only going to give you one, not two Franks. Let's say that we wanted to find all the matches though. This might be useful, especially if we're trying to do something like, count the times that something appears. Like, how often did Frank do validation versus Bill? Who's more efficient at their work, for example? We can use the find all method. This quite literally will be used to find all matches within the string. So as we're going from computational efficiency speed, match is the fastest, search is slightly slower, and then find all is going to be slower than either of those because it looks for all of them and returns all of them when found. Same calling method where we provide a pattern and a string. And in this one, it gives a slightly different return object. So if no object is found, we'll get an empty list. But if we do get matches, then it's going to give us a list of the match strings. When we have no captured groups, or if we have captured groups, it's going to give us a list of tuples where we've got the pattern or from which our pattern gave the captured groups. Unlike the search mechanism, findall will not give us a match object and does not provide us a start and stop position or a span. Now, it does look through all non-overlapping strings, so that's just one thing to be aware of as well. As we go into an example, this I've actually provided a separate data set for. So you can go onto Project Gutenberg, and they have all the free public domain texts available out there, or at least some of them. So I downloaded Alice in Wonderland by Lewis Carroll, and the dialogue is a little older, in terms of English than what we use today. So a lot of times, for example, in the document and in the book, they'll say something like "said the king," "said the queen," "said the blank," like insert your noun. Well, let's say that we wanted to update this and make it more modern, easier to read for little kids or younger readers. Someone who just wants it more linguistically, up to date. So if we want to change it from "said the queen" to "the king said" or "the queen said," and so on, we can use regular expressions. So to start off with, let's just see if we can find all instances where "said the" occurs in the original text. So I'm going to go ahead and open the file. This is a text file, so we'll just use the with open command, and it's UTF-8 encoding. We'll give it the pattern. Now, keep in mind, when we're constructing these patterns, "said the king," "said the queen," or "said whatever," that could be the very beginning of a sentence, or it could be somewhere in the middle. So we might want to consider having upper or lower case. That's why we've got this character class to start off with for the pattern. And then we can do, again, our simple re.findall method. So let's go ahead and run that. So I've got our command for reading the file, and then I'm going to apply the pattern matches to it. To start off, though, just so that everyone can see it easily, I'm first just going to load the file. So I've got this text equals file.read. I'm going to open up a line below. We'll copy this code down, bring it in. But let's just give you an example on that text. It's going to be pretty long, so we'll hide it afterwards. But it'll give you a flavor for what it's like to load a full book. And you can see that we've truncated it in the output of the cell, but we've got it here. So this ebook is used, yada yada, where it's from, release date, credits, illustration, and if we wanted, we could go through the entirety of the text. Okay, now we have our pattern that we want to match on and apply re.findall to. We're going to apply that, and we can see that in the book Alice in Wonderland, there are 197 matches where "said the king," "said the queen," "said something," were found. Now, again, what if we want to replace these? We'd want to do a substitution. So we can do a substitution using re.sub. So the re.sub is a little bit different from findall, match, or search in that we provide first the pattern we want to match on. Then we provide the string that we want to replace something with. So it's the replacement argument. And then that is followed by a string. If we don't get a match, obviously, then nothing happens. The original text is provided unchanged. If we do get a match, then we replace the string with the argument that we've provided in its stead. So it will transform the text by replacing the matching pattern. That's kind of key. It's not going to give you a list of matches or a specific list back. It's going to transform that text as you request it. So going back to our "said the king," "said the queen" example, we're going to use re.sub to see if we can substitute and backwards replace from "said the" to "the blank said." So the way that we would do that in our replacement, we can just, since we've captured "said the," we can create that as one group, and then as a second group, we can put the name or the noun object. And so we can just do an A to Z upper and lowercase catch repeated multiple times to get the noun captured. And then for the replacement, we'll just give the, and then we want to provide the second matching group. So that's where our /2 comes in. And then said. So the noun said versus said the noun. So we'll go ahead and do that. So, we've got that text open. We've got the pattern for replacement. Now, I will say if you're running in Jupyter, you don't have to keep doing this with open text file.read. But if you're running in Python, keep in mind as you're operating with your functions, the data that's not retained is lost. And so just make sure that you're explicit in terms of how you're retaining the information. It would be rather inefficient to load this 5 or 6 times. Anyway, we'll go ahead and run the pattern. So we've got our pattern that we have here, and we want to replace it with, and then our updated text. So let's go ahead and do that. And I'm just going to execute. I'm going to delete some of this first so you can just see that this runs. Okay, so we don't get an error out, and we've got our updated text. Now that might be handy, but there's a problem in that you can't really tell in a massive document, whether or not it did everything the way that you wanted it to. So I just have some quick code to just demonstrate that we have those matches. So I've got the old text and the new text, where we've got the old pattern, said the, and the new one, the noun said. Now, since we've done an update, we shouldn't be able to find old matches. If we don't, then we've done it successfully. And then we'll just print off a few of the matches we now have. Perfect. So we have all the matches replaced. And you can see here that we've got the Duchess said, the cat said, the Hatter said, and similar. So that works out pretty well. Now let's go to the last function that we said we would cover today, and that is the subn function. So what's the difference between re.sub and re.subn? Well, the subn provides a counter. And so instead of just giving you one object, the substitution, it will give you the number of times that it's also executed that substitution for. So that might be handy if you want to keep constant track of those replacements. Maybe you've got a type of mechanism where you're doing a metric tracking for it, and where that is essential to have. Again, if no match is found, we're going to get the original string returned, but this time we'll also get a count, which is 0, because it matched or did 0 replacements. If we're going to go on this one, same process, right? We could do the king said, the queen, changing that, and then use re.sub. So I'm just going to change the operation slightly, and just from sub to subn. That's really the only change that has to happen here. Is just this little character here being sub versus n. We'll go ahead and run it. Okay, and then we print off the first 500 characters, and we also have the replacement count. So quickly we see we've got 199 replacements that happened. And then also we've printed out the first 500 characters from the text. Okay, so just to summarize, in this notebook, we've demonstrated how to use the match, search, find all, and substitution, and subn methods. As we're talking about speed, if you're trying to find a match to a particular string, and you don't need to replace it, you don't need to do anything with it, you just need to find it, match is the fastest, assuming that it starts at the beginning of your string. Search would be the next fastest if you only want to pull the first match from that string, but it could occur anywhere within that string. Find all is the most all-encompassing. It's going to give you all matches from that string, wherever it's found. And then if you need to do substitution where you're trying to change it out, you can use re.sub or subn based on whether or not you want to count. These are 5 pretty basic functions in regular expressions. They tend to be the ones that you'll use the most, at least the ones that I use the most. If you have found this lecture helpful, go ahead and subscribe. If you want one-on-one tutoring or a project you'd like to tackle, we always offer consulting services for a fee, and you can reach out at info@envirolytica.com. In the next lecture, we're going to cover the other Regex expressions, such as split, full match, find iter, escape, purge, and compile. So go ahead and check out that video next. But that's all for today. And if you want practice problems, we do have extra practice problems in a subsequent video as well. And you can download those practice problems on our GitHub site so that you can go through crafting. The data is available as well, so if you want to crunch through the contact directory, report files, or Alice in Wonderland text, you can go through that. As I mentioned the directory, we went through a brief loading of that. The practice problems go through how to slice and dice the data so that you can pull from the directory in that lecture practice problem workbook. So thanks again. Hope you have a wonderful day, evening, whatever it is. And go ahead and subscribe, and we'll see you again soon.